This video shows you how to conduct a cluster analysis using the wine promotion data. Before you conduct this analysis, please review the relevant slides on what cluster analysis does. So as you see, this Excel file actually has two sheets. One sheet is named offer information. So this sheet gives you the promotions the company actually run over the year. So the campaign goes from January to December, and the variety of the wine that is being promoted, and the minimum ordering quantity on the promotion, the percentage discount, the origin of the wine, and whether the wine has passed peak. So this is the offer information. And the second sheet, it's called transaction. So this sheet gives you the record of customers. So these are customers' last names. We get a list of customers and what offer they have taken. So for example, the customer named Smith has taken offers 2 and 24. Johnson has taken offers 17, 24, and 26. To better conduct analysis, let's first convert this offer data a little bit. That gives a clear presentation of who has taken which offer. We use a pivot table. So let's do insert pivot table. And now the range is automatically selected. We just click OK. So we want the offer numbers to be in rows. So drag this to rows. We want the customers to be in columns. So we drag this to columns. And now we see a big matrix of offers by customers. And next, we want the data table to show us who has taken what offer. So in this case, we just drag customers' last names into values. Since customers' last names are text, so automatically it's going to do a count on this. For example, Butler has taken the first offer, then it marks as 1. If not, then it's basically empty. So this is the pivot table we get. We want to copy this pivot table out and just use the data. So that's what we're going to do next. First, let's name this sheet as pivot, so we know what it is, and change the sequence a little bit. So this is after transactions. Okay. And next, let's generate a new sheet, and let's name this new sheet matrix. And on this sheet, first we copy the offering information. So let's Control-Shift right down, Control-C, and then back to matrix, and then we paste this, Control-V, and then we copy the who has taken what offer information from this sheet. Let's copy the whole table so it's easier to do it that way. Control-Shift right and down, and Control-C, and to matrix. Let's say we only want to paste the numbers. We don't want any format and other things to be pasted. So then we focus the mouse cursor here, cell G1, and right-click your mouse. And as you paste, you have different options. In this case, we only want to paste numbers. So we choose this one with 1 to 3 here. Left click. So we have basically copied this whole matrix here, but some of these are things we don't need. Since if you look at this, oops, I forgot to copy the part of the information, I think. Okay, so didn't copy offer number. Let me copy this here. Control-C, matrix, and select the first column, right-click, insert copied cells. So now we have a copy offer number into this. So once we have this full information, then this column is actually useless. Let's get rid of it. Right-click, delete. And the last row, this is the sum of the column from generated by the pivot table. We don't need that either. Right-click, delete. And the pivot table also does a sum of all the rows. If you scroll to the very right of this table, you can actually see grand total here. We don't need this. Right-click, delete. So now we have the data for analysis. Let's create another sheet and call it 4MC. So this stands for 4 mean clusters. And on this sheet, we copy this whole table we just created. Control-Shift, right and down, and Control-C, and back to 4MC, and Control-V. So we copy all the data file here. So in this case, we want to see how it looks like if we create 4 clusters and basically categorize each of these customers into the 4 clusters. In order to find out where the 4 cluster centers are, we need to use Excel's solver function. But first, let's lay the thing out. Let's create 4 columns. So select 4 columns and right-click and insert. So this gives us 4 empty columns. And we want to name them cluster 1, cluster 1. And you name the first one, you just drag it, Excel is going to automatically recognize you want 2, 3, and 4. Okay. So right now we know nothing about where the cluster centers should be. And let's put in some basically dumb values here. Let's put zeros, all zeros here. So let's freeze the panel so that when we scroll around, we still know what is what. So let's do view, freeze panels. See, when you put the mouse cursor here, if you select the first one, freeze panels, it's going to freeze the top and anything to the left. So that's what we want. Okay. And now it has frozen the top and the left side of it. The next we want to calculate is each individual's distance, how far they are from the center of each cluster. So let me first label this so that we know what we are going to calculate. All right. So distance to cluster 1. And then if we drag this down, it will have distance to clusters 2, 3, and 4. And then we want to calculate out of the 4 distances, each individual to each of the cluster centers, what's the minimum distance. Let's say an individual's distance is the smallest to cluster 4, then we can assign that individual to that cluster. So the next information we want to put down is assigned cluster. Okay, so these are basically the things we want to calculate next. Move on to this cell. This is the first individual atom. We want to calculate basically the Euclidean distance between atom and the cluster 1. So let's start with the very basic calculation here, and we'll add more things to make this equation foolproof. Let's select all the DO records from atom minus what we want is basically how far this is to the center of cluster 1. And to do the Euclidean distance, we need to take a square of this difference. Let's enrich this equation. So this basically gives us all the differences between 0 and nothing, 0 and nothing, and only in this case 0 and 1, etc. So we want to actually sum up all these squares of differences. So we're going to take a sum of it. And on top of it, because this is basically the square, what we have here is basically the square of distance, and we want to take a square root of it, so it's SQRT. Okay. So this gives us basically the calculation of this distance. Then the next adjustment we want to make is we want to make this specific equation easily copyable to the other cells so that we don't have to make adjustments wherever we copy this equation to. If we do any distance of all these individuals to cluster 1, it will always basically refer to the location of cluster 1. So we should just anchor the location for cluster 1. Let's put $signs in front of columns and the rows here. So then wherever we copy this equation, these references will not change. And also on the individuals, the data always falls between the second row and the 33rd row. But the columns might change for different individuals. So which basically means the row number should not change when we copy this equation. So we anchored the row numbers. Now we pretty much have everything we want on this equation. Press enter. Okay, now we have the first equation. Let me copy it down to the other 3 clusters. And then let's check each one of them. At cluster 2, when we look at it, since we have anchored the cells, So cluster 1 has been anchored. We have to do a little bit of adjustment on moving this to cluster 2. So it moves from column H to column I. Okay. And the next one, we change it from H to J. And the fourth one from H to K. So now we have settled on all the four distances. And then we need to figure out what is the minimum distance here. Okay. And the next is based on which distance is the smallest. I'm going to assign this individual to a cluster. And there's actually a very convenient function in Excel. It's called a match. So what match does is we want to look up the value. We want to look for the minimum distance. And we are looking for the minimum distance in this column of distances. And then when that minimum distance matches one of the distance to the clusters, I'm going to assign that individual to that specific, the closest cluster. So in this case, the next parameter in match is choose less than exact match or greater than we want exact match. So it's 0 here, and then just return. Since all the values are the same, it basically assigns it to the first match. And now we have the first column. All we need is drag this down to all the individuals. Then we get all we need. All right. Okay, so now we have calculated this across all individuals. Ultimately, what we want to do is let's do a calculation of the total distance of each individual to his or her closest cluster. So what do we want here is basically a sum of the mean distance. This is the value that we want to minimize. We want to find the cluster centers such that the sum of all these individuals to their cluster centers are as small as possible. So we want to minimize this. And that is where we start to use the solver. So click data, solver, and in this case, the objective cell in this case is L41. That is this one. We want to minimize. You can maximize it, minimize it, or set it to a value. So we want to minimize the total distance by changing the cluster centers. So select all the cluster centers we have. And next, we want to add a constraint to this. We know it's taking or not taking the deal. So these values will be bounded between 0 and 1. But let's add a constraint that these values are less than 1. Okay. Technically, we can also set the lower bound, but there's a default option here, make unconstrained variables non-negative. So it already automatically, in this case, does not allow it to drop below 0. So we don't need to add anything else. And next, we need to select the solving method here. If you click on this triangle, what you'll see is Excel actually provides 3 different engines for optimization. One is called GR nonlinear, so this basically solves nonlinear optimization problems. There's the linear programming solves linear problems, and then there's evolutionary, usually solves very nonlinear messy problems. So this is the one we need. Let's click evolutionary, and then you can actually set some of the options here by clicking options. This back. So by clicking options, I see you can set options for evolutionary. Here you can set different convergence standards. So the smaller this value is, the longer or the more difficult for this for the solver to judge it actually has reached optimum. So let's make it a little bit smaller than this, adding 1, 0. The mutation rate. The evolutionary method, as you could imagine it actually solves it. It jumps around on the field to try to find the optimal top. And the mutation rate dictates how fast these points jump around. When you have a smaller value, you can get more refined results, but you might have a higher chance of missing the global optimal. When you have a larger number, let's say we double it, set it to 0.15. And when you have a larger number, then you jump around faster, but it may take you longer time to reach the optimal solution. And the population size is how many points does Excel start to run optimization. Random seed, you don't have to change it. It really makes very little difference whatever you do. And then the maximum time without improvement. So if for 30 seconds the solver does not get a better value, then it's going to stop. Let's extend this a little to 300 seconds. So this basically will give you about 5 minutes. That should be sufficient time for it to do the job. So these are the options we set. And click OK. All right, so now we're back to the interface. Next, I'm going to just hit the button
Solve.
Then solver is going to try to minimize the distance. This may take a while. Click solve. And then let's see on the lower left, this incumbent indicates how the minimum distance has been optimized. As you see, we're trying to maximize it. So it has been decreasing, and decreasing. Program is going to stop once it reaches both the optimal value. And there are a couple of things that I want to emphasize here. One is, as you see, cluster centers 1, 2, 3, 4. There's nothing force cluster 1 to be a specific center. So if cluster 1, 2, 3, 4, if the label actually switch around the same locations, but cluster 1 becomes cluster 2 becomes cluster 1, it will make absolutely no difference in the results. So when you run solver more or less randomly, your label of the clusters would be different from individual to individual. Chances are you may get a different label of clusters, but your solved cluster center locations should be fairly close to each other. That's one thing. And the second is, since we are using a simulation-based solver, evolutionary solver, one of the issues with this simulation-based method is each person or each time you run the analysis, you are actually going to see a slightly different results. So the results will not be identical each time you run analysis. But generally, that should not change your results directionally. So you should not have something ridiculously different, but just in a minor way, the results may differ. Okay, this actually is done here pretty fast. So we can keep the solver solution and just click OK here. As you see, this value has been decreased from 170 something to about 140. So in this case, as I have seen it, the results sort of varies somewhere between 139 point something to about 142. So that's the range I have seen. So now you see the solver actually has changed all these cluster centers. These are the values we're trying to solve. So let's back to home and we keep a smaller number of decimal points. So we keep 3. Let's keep 4. Okay. And then the next thing is you want to see the magnitude of these numbers more clearly. And then you can actually do a conditional formatting, color scales, and use the green-white scale. Click OK. So now you see the high values here are highlighted. And what we want to take a quick look is we want to actually see each of these cluster is. In order to do that, create a new sheet. Let's call it, I will click 4MC top deals. So first, let's copy the deal information to the new sheet. Control C, new sheet, Control V. And then we want to look at each one of these 4 clusters. So let's put 1, 2, 3, 4 here. I didn't put a cluster in it because I want to use them as numbers. This would be for ease of calculation. And let's stretch this out so we can see the information of each column. And then let's center the first row. Okay. So now I want to calculate the number of people from each one of these clusters. How many people have taken each one of these offers? So to do that, we need a function called SUMIF. So let's type equals SUMIF left bracket. So in this case, what SUMIF does is you need to basically pick a range, and if the value in that specific range equals a criteria, another value on the set, then you can take sum of another range. And in this case, the range you want to pick is actually assigned clusters of each individual. Okay, and comma. Now come back to 4MC top deals. If the assigned cluster matches this, matches 1,
That should sum up the people from cluster 1 taking the deal.
so where do I find people's record of taking the offers? It's again back to the 4MC sheet. And this would basically be the second row here of each individual, whether they have taken the deal or not. So we want to select all the way, want to sum this up. Right. And now let's come back to the sheet we want to look at. So in this one, what we have here is we want this equation to be more easily copyable. So one thing, we should not be moving the assignment of the clusters around. So that is anchored. And second, the top one we want to match is always in the first row, 1, 2, 3, 4. So this, we anchor this as well. And then the sum of the deal taking records. So the row actually would roll down when we look at the different deals, but the columns would always be between column L and column DG. So we anchor this as well. So return. And now we can easily copy this equation around. So here, let's go down. Let's color this, conditional formatting, color scales. So we want to make this table, this whole table, a little bit easier to sort. Let's do data and then click filter. So as you see, it added these small manipulations here. So this allows you to do, let's click on this, allows you to easily sort the table by each one of the columns. You can sort by color, and you can actually make a selection of which of the numbers you want to play. So in this case, let's say we are sorting numbers from the largest to the smallest. The reason why we sort this is we want to get some idea of what each one of these clusters actually mean. So, so in this case, cluster 1 is quite obviously people only taking offers on Pinot Noir. So this is Pinot Noir segment. And let's see, set cluster 2, largest to smallest. And this cluster is actually, if we look at the variety here, this cluster are the people who are pretty much taking offers only on sparkling wines. And then cluster 3. This cluster is a little bit difficult to interpret, so as it may happen from time to time. So you have a mix of large and small offers. The discount has no direction. The origin has no sort of obvious pattern. And the varietal, you have champagnes and Chardonnay and Prosecco. Really, there's really not much you can interpret this clearly. So this, we are not sure how to interpret this sector. And then cluster 4, from largest to smallest, this actually has a clear pattern. So as you see, the minimum quantity for ordering is all very small for cluster 4 people. So these are the very small order people. So as you can see, by doing this clustering, we can actually instantly interpret 3 clusters out of this analysis. And once you have the clustering, you can actually design your campaign more effectively. For example, the campaigns can be more targeted towards a specific group of individuals when we know their interests better. And it also makes it easier to understand how the market sort of splits out in terms of when they take different types of offers in the market. And let's sort back the offer here. So this completes the analysis of using Euclidean distance to do a cluster analysis.